So, I want you to picture this. A maintenance director for a massive industrial operation recently sat down after deploying this multi-million-dollar state-of-the-art sensor network across his entire fleet.
Right.
He had the dashboards, he had, real-time telemetry, absolute cutting-edge
A
technology.
whole package, essentially.
Exactly. And when someone asked him how it was going, he said something that just kind of blew my mind. He said, "We can see every problem before it happens, and we still miss most of them."
Oh, man. That is just,
Yeah.
it's a brutal admission. I mean, it completely shatters the illusion of what modern technology is supposed to do for us.
It really does. Because when you picture one of these facilities, you imagine something straight out of a sci-fi movie,
Yeah,
right?
absolutely.
Like a massive plant at dusk, floodlights shining, but layered over the physical machinery is this flawless digital nervous system.
Right, with the sensor icons buzzing with data, anomaly detection firing in real time.
Yes. Technicians walking the floor with tablets streaming gigabytes of telemetry. I mean, it projects total control. You have perfect visibility.
But the reality is the operation is fundamentally failing.
Exactly. And so, why does seeing the problem perfectly not translate into solving it? That is our mission for you today in this deep dive.
Yeah, we really need to unpack that.
We are exploring that hidden gap between predictive detection and reactive execution. We're going to dive into how the most advanced sensor networks in the world are silently failing the operations teams that rely on them.
And, to do that, we have to look past the flashy dashboards.
Hmm.
Because the issue here isn't the technology failing to detect a problem.
Right. The sensors are working fine?
They're working flawlessly. The issue is entirely about what happens, or, well, rather, what fails to happen, in those dark spaces right after an alert is triggered.
Let's get right into the mechanism of that failure then.
Yeah.
Because to wrap your head around how you can see a problem and still somehow miss it, you have to look at the immediate aftermath of a successful detection.
Yeah, and you see this happening out in the field in just incredibly frustrating ways.
Oh, I bet. Like what?
So, for example, a critical temperature alarm on a commercial compressor fires flawlessly at, say, 2 a.m.
Okay.
The threshold breaches, the system catches it instantly. But, and here's the kicker, nothing happens until the morning shift manager logs in with their cup of coffee at 8 a.m., looks at the screen, and sees a red icon.
Wow. Which completely negates the entire value of early detection.
Exactly. You bought 6 hours of lead time and just immediately threw it in the trash because the system relies on a human eyeballs on glass approach to acknowledge the data.
That is so frustrating. Or, take a more complex scenario. Like, let's say you have a highly sophisticated vibration sensor on a turbine.
Right, using machine learning to analyze the acoustic signature of a bearing.
Right. And it doesn't just say, hey, this is broken. It predicts with stunning accuracy that the bearing will completely seize in exactly 3 weeks, which is brilliant.
It is brilliant.
But the actual work order to dispatch a human being out there to fix that bearing, that doesn't get created until 2 days after the machine has already catastrophically failed.
Yeah. And that specific scenario highlights a massive, massive structural flaw in how these businesses operate.
How so?
Well, the predictive analytics engine, the software that's actually doing the math on that vibration data, lives in a completely different ecosystem than the ticketing system.
Oh, I see.
So you have this genius-level AI predicting the future, but it has absolutely no direct pathway to automatically trigger physical labor.
That's crazy.
Right. Somebody has to manually extract that insight, interpret it, write up a ticket, and then log it into a totally different platform.
And while that paperwork is just, sitting in a queue, the machine breaks.
Exactly.
It's like, okay, it's like having a $1 million home security system. It detects a burglar the exact second they touch your front lawn. It records them in crystal clear 4K resolution.
Right.
It instantly sends a high priority push notification to your phone. The detection system worked perfectly.
Flawlessly.
But you still have to manually wake up, find your glasses, look up the local police department's 10-digit phone number, wait on hold, and verbally explain your address to a dispatcher.
All while the burglar is already standing in your living room.
Exactly.
And the tragic part of that home security scenario is that while you are fumbling for the phone, you are actively losing the one advantage that multi-million-dollar system was supposed to give you.
Time.
Time. Yeah.
And this reveals a fundamental shift in where the true value of predictive maintenance actually lives today. For decades, the industry was just obsessed with this arms race of awareness.
Like, how many sensors can we install?
Right. How rich is the telemetry data? How early can we spot the degradation?
Basically, everyone just wanted more dots on the map.
Exactly. But getting dots on a map no longer defines the outcome. As operations have scaled up, the value has moved entirely into execution.
Because it doesn't matter how early the signal was detected if the execution layer is broken. Yes. Is the work order created automatically? Is the technician dispatched with the full context of what the sensor actually saw? Is the job completed before that 3-week failure window closes?
Right. Those aren't monitoring outcomes.
No, those are operational outcomes.
So the operations teams essentially build this mental model where they just stop trusting the multi-million-dollar system altogether.
Yeah, they realize the glowing dashboard isn't actually an execution engine. It's just a highly advanced suggestion box.
A suggestion box. Wow.
And from the outside, like from the executive boardroom, the system looks highly functional. The IoT platform logged the data. The analytics tool generated the chart.
Right. The executives are happy.
But those boardroom dashboards do not capture the chaotic manual scramble that happens in the shadows to actually get a human being out to the machine.
Well, let's dig into that chaotic scramble because I feel like this is where the execution really starts to drift.
Yeah, definitely.
The underlying mechanism causing this failure isn't a lack of data, right? It's the friction between the systems.
It is death by 1,000 API handoffs.
Huh.
To understand why this fails, you really have to look at the architecture.
Okay, lay it out for us.
So the IoT platform, the system catching the sensor data, is designed to process millions of telemetry pings a second. It handles voltage drops, temperature spikes, pressure loads,
Right.
but it doesn't know anything about human beings. Then you have the Field Service Management Platform, or FSM. That is your operational brain.
Got it.
It knows technician schedules, truck inventory, geographic routing, and customer service level agreements.
So you basically have a machine brain and a human scheduling brain.
Exactly. And the friction happens because these two systems speak entirely different languages. The IoT system throws an alert over the fence, but the FSM system just sees a generic text string. The data schemas just don't map perfectly.
So all that rich context just gets stripped away during the handoff.
Yep.
You end up with a technician arriving on site staring at this massive piece of infrastructure, and they literally have to call base to ask which specific sensor triggered the alert.
Because the telemetry data existed in the IoT platform, but it didn't transfer over to the tablet they were holding.
Right. Or, a job gets scheduled based on a generic calendar window-like Q3 routine checkup, completely ignoring the specific 3-week degradation timeline the sensor just provided.
Which means you are doing the wrong work at the wrong time, despite having perfect data telling you exactly what to do.
But wait, if you're listening to this and you're managing a team right now, you might be thinking, well, if I see a flashing red light on my monitor indicating a pressure drop on valve 3, I just radio my technician and say, hey, go look at valve 3.
Right.
It doesn't seem that complicated. Why does that require some massive systemic overhaul? Why can't teams just communicate?
Because you are picturing one valve and one technician. When you scale this up, the math completely breaks human communication.
Scale is the killer.
Exactly. In the early stages, with maybe 10 or 20 connected assets, your manual workaround is totally fine. A quick call, a Slack message, there is enough visibility for everyone to just stay aligned. But what happens when you go from 10 sensors to 10,000?
Oh, man. The volume of alerts just buries the dispatcher.
It buries them. But it also changes the very nature of the job. Monitoring isn't just about spotting a red light anymore. It requires complex filtering, prioritization, and routing across multiple operational conditions in real time.
Right, because you have to ask, is this red light a critical failure or just a temporary spike because a machine started up?
Exactly. Does this need a technician today, or can it wait until next week's scheduled visit? Manual coordination completely collapses under its own weight because human beings literally cannot process and triage thousands of concurrent signals.
And the deterioration of the operation, it doesn't happen with some giant cinematic explosion either, does it? It's much more insidious.
Yeah, it builds gradually. Instead of massive visible breakdowns, operations suffer from these micro delays, small gaps and inconsistencies.
Like information arriving slightly too late?
Yes. Decisions being made with partial context. It's this increasing coordination overhead that slowly exhausts your workforce.
Wow.
Your dispatchers are no longer managing maintenance. They are managing the sheer effort required to keep the monitoring system aligned with the execution system.
So you're managing the friction, not the outcome.
Precisely.
And that internal exhaustion eventually has to leak outward. I mean, if the dispatcher is overwhelmed trying to stitch two software platforms together, the technician is dispatched late, they arrive without the right context.
And who actually pays the price for that broken data handoff?
The customer.
The customer. Their reality is that they feel every ounce of that internal friction, even if they can't see the sensors. They do not care about your cutting-edge IoT platform. They only evaluate the outcome.
They notice when they have to follow up to confirm timing.
Oh, absolutely.
They definitely notice when they have to repeat information to a technician standing in their facility, information they already told the dispatcher on the phone 3 hours ago.
Right. Or they notice when the scope of the job suddenly changes because the technician didn't have the real-time sensor context.
And every single time a customer has to bridge that gap for you, your multi-million-dollar predictive service feels entirely reactive.
Yeah, it might be functionally repairing the machine, but it doesn't feel reliable. The entire customer experience is shaped by how consistently information flows from detection into execution.
So when that flow is broken, your predictive maintenance is just standard maintenance with a fancier warning light.
That's exactly what it is.
So if I'm a manager and I'm watching my dispatchers completely drown in this translation effort and my customers are getting annoyed, my immediate instinct is to pull the human out of the middle.
Right.
I'd just buy an automation tool, write a script. If pressure drops below X, automatically generate a work order and dispatch a technician. Boom, problem solved.
Which is exactly what companies do. It is the most natural reflex in modern business.
Okay, but...
And it's exactly why they crash and burn. This is what we call the automation trap.
Okay, unpack the automation trap for us. Because on the surface, automatically converting alerts into work orders sounds like the definition of efficiency.
It fails because automation works entirely on top of existing structures.
Interesting.
If your workflows are deeply connected and the data maps perfectly between systems, sure, automation enhances them. But if your workflows are fragmented, if your API handoffs are dropping context, automation doesn't solve the problem. It just weaponizes it.
It weaponizes it. Wow. Okay, it's like strapping a jet engine to a bicycle.
Yes.
I mean, yes, you are moving much faster, but you're just going to crash sooner because the underlying structure wasn't built to handle that speed?
That is exactly the mechanism at play. To get slightly technical for a second, standard automation usually relies on rigid if-then triggers.
Right. Like if the temperature spikes, then create a standard repair ticket.
Exactly. But standard automation lacks what we call stateful awareness. It doesn't understand the nuance of the physical world.
What do you mean by that?
Well, it doesn't know that the machine has a 3-week degradation curve, or that a technician is actually already scheduled to be at that facility tomorrow for a totally different issue. So it just defaults to a standard 24-hour service level agreement.
So it brings incredible speed, but it completely destroys clarity.
You generate work orders instantly, but they aren't the right work orders. You schedule jobs at lightning speed,
Right.
but with completely the wrong urgency.
Right.
From the outside, your dashboard shows incredible efficiency, like thousands of automated actions processed per minute.
But out in the field...
Out in the field, technicians are running around with generic, stripped-down work orders to fix machines that either aren't broken yet or broke 2 days ago.
You are basically just making mistakes at a massive scale.
Exactly.
You've sped up the chaos. The underlying issue hasn't changed at all. The sensors detect, the platform alerts, but the actual meaningful physical work still begins entirely out of sync with reality.
And this is exactly where the maintenance director from our opening quote finds himself. He deployed the sensors, he tried to manage the alerts manually, his team got overwhelmed. He tried to automate the dispatch, and he ended up generating thousands of pointless work orders. He can see every problem, and he's still missing most of them.
Man, we have painted a pretty bleak picture of modern industrial operations here.
It can be rough out there.
Manual effort fails when you try to scale it. Automation just amplifies a broken manual process. The internal teams are exhausted. The customers feel like the service is reactive.
Right.
The executive leadership is left wondering why their massive technology investment isn't moving the needle. So how do we actually close this gap? What is the architectural fix?
The fix requires a fundamental shift in philosophy. We have to move away from effort-based alignment and move towards system-based alignment.
Effort-based, meaning relying on human beings to manually stitch things together with, phone calls, Slack messages, and swivel chair data entry between two screens.
Precisely. For too long, the solution to poor coordination was to just add more oversight.
Like just add another dispatcher.
Yeah, or build a new dashboard to watch the broken process. System-based alignment means designing a workflow that eliminates the need for oversight in the first place.
Systemic alignment.
Yeah.
Okay, so if we look at platforms designed to solve this, like Dusk FSM, which acts as that central nervous system, how does the data actually flow in a systemically aligned environment?
It means the workflow is inherently and natively connected. The data models share the exact same language.
So no translation needed.
Right. When an anomaly is detected by the IoT platform, the work order isn't just automatically created. It is created with the full, rich context of the sensor payload seamlessly embedded into the ticket.
So the telemetry data, the degradation curve, the specific machine history, all of it lands directly on the technician's mobile device.
Exactly. They don't have to call back to base to ask what triggered the alert because they are looking at the exact same data the machine generated.
And the scheduling engine isn't using a dumb if-then rule either, right?
No, it uses the real asset conditions. If the sensor predicts a failure in 3 weeks, the system evaluates the routing, looks at the technician's future availability, and intelligently schedules the intervention for week 2.
Oh, wow.
Yeah, bundling it with other preventative maintenance in the exact same geographic area.
It's context-aware execution, and this extends to the customer as well, right? Customer updates are tied directly to actual physical progress in the field, automatically.
Exactly. The customer never has to call to follow up because the system itself is maintaining the alignment between the machine, the technician, and the end user.
This feels like the critical turning point for anyone managing field operations. This completely rewrites the definition of what makes predictive maintenance valuable.
It does.
And this is the aha moment for you listening. True predictive value isn't about that exciting, sexy moment of a dashboard flashing red and an AI detecting a microscopic anomaly.
That's just the starting line.
Right. True value is about the incredibly boring, beautiful absence of friction in getting the physical job done.
The beautiful absence of friction. I love that phrasing.
It is about the technician walking up to a massive industrial compressor, already knowing exactly what is failing, with the exact right replacement part in their hand, arriving days before the customer even knew they were at risk of a shutdown.
When intelligence flows seamlessly into execution without losing context, your operations actually become predictable.
Wow.
Your dispatch teams stop spending their entire day translating alerts between software platforms, and they finally spend their time strategizing and executing the actual work.
And that brings us full circle back to where we started.
It really changes the entire paradigm. We move from that frustrated reality, we can see every problem before it happens, and we still miss most of them, to the reality that technology promised us in the first place.
Right.
We can see every problem before it happens, and now we actually do something about it.
And now we actually do something about it. That is the ultimate goal. That is the promise of systemic alignment. Okay, let's pull all these threads together and distill what we've learned today in this deep dive. We started by unpacking the illusion of visibility. We learned that having perfectly functioning sensors, massive data lakes, and cutting-edge anomaly detection is really only half the battle.
A very small half on.
Right. If your digital architecture relies on humans to manually bridge the gap between a digital alert and a physical dispatch, your predictive maintenance is fundamentally broken. It will inevitably collapse under the weight of its own scale as your asset network grows.
And we also explored why you cannot simply automate your way out of that fragmented workflow.
Right, the automation trap.
Because if your systems don't share the same context, automating a broken process just creates faster, louder chaos.
True scale requires alignment built right into the architectural workflow. The system has to flawlessly carry the context of the sensor's alert all the way down to the technician's wrench without a single drop in fidelity.
But as we achieve this, it raises a rather profound question. A provocative thought for you to mull over as you go about your day.
Ooh, let's hear it.
Let's say we spend the next decade perfecting this systemic alignment. The systems perfectly and automatically connect sensor telemetry straight to the technician's tablet.
Okay.
The algorithms schedule the dispatch flawlessly, balancing degradation curves and geographic routing, entirely bypassing the human dispatcher. If the machine becomes perfectly self-coordinating, What happens to human intuition in field service?
Oh, wow. That is a heavy thought. If the algorithms handle all the coordination, do we eventually engineer the human decision maker out of the loop entirely?
And if we remove the human from the triage process, what nuances of the messy, unpredictable physical world might those perfect algorithms miss? Nuances that only a human dispatcher, someone who knows that a specific technician works best on a specific type of legacy machine, would catch.
If the system is perfectly frictionless, do we lose the human spark that sometimes catches the truly unexpected context?
It's definitely something to consider.
Think about that next time you look out at a massive industrial facility glowing with all those perfect digital overlays. We've loved sharing this deep dive with you today. Thank you for joining us and keep questioning the systems around you.